So now we're going to introduce matrix multiplication. So this is going to be a little bit more challenging if you do it by hand. I mean, the calculator, again, takes care of it. You don't have to do it yourself. But there is a set of rules we have to follow with matrix multiplication because we kind of define it in a different way. And so the way we start first is we're going to define two matrices. So given, or actually let's say the word let A be an M by R matrix, and there's a reason I choose R, and you'll see in a moment. And let B be an R by N matrix. The product, or multiplication, of A times B. So when we multiply two matrices, we usually just put them next to each other. We actually don't put anything in between them, but you can. You don't have to. I wouldn't put a dot between them because we kind of use that for dot products in matrices, so be careful with that specific one. It's going to be as follows. So you kind of have to have this rule, like this condition to be able to multiply. So take the dimension of your first matrix, M by R. That's A. And then you multiply it by B, which is R by N. B. Okay. As long as these two right here, these two numbers, are the same, then the product is defined, and the resulting matrix will be the two outside numbers, M by N. There and there. So that's how you multiply two matrices, essentially. You have to make sure that the two, I say the two inside numbers, they multiply, they are equal to each other, I should say. So as long as the two inside numbers are equal, they multiply. So let's just practice that first, and then we'll actually learn how to multiply them. So A is 2 by 3, and B is 3 by 2. What is the dimension of their product? And if you can't multiply them, then you just say it's undefined. So 2 by 3 times a 3 by 2. These right here, they are the same, which means my resulting matrix is 2 by 2, like that. And again, we'll do some color coordinating here so you see where they come from. And there you go. We're allowed to multiply these two matrices as long as the two middle numbers are the same. Now, what if we have something that is not the same? Okay, so A is a 2 by 4, and B is a 2 by 4. What is the dimension of their product? Well, 2 by 4 times 2 by 4 is equal to, well, I look at these two numbers, not same, so undefined. Can't multiply them. Not allowed to. They don't meet the condition to be multiplied. Now, if you have two square matrices, they will always be defined in terms of multiplication. A is 3 by 3, and B is 3 by 3. What is dimension? Well, 3 by 3, 3 by 3. That's just 3 by 3 because they're all the same number. So that's the same. So we're good to go. Now, one way they can trick you, honestly, is they give you A and B, and then they tell you to do B times A, right? Like they could always do that to you. They could just be like, hey, Let me give you a mix-up of the dimensions, right? Or the letters, so got to be careful with that. And they could also make it a little bit more challenging by making you do something like this, right? So here's the last example. Given A is 6 by 4, B is 4 by 7, and C is 7 by 6. What is the dimension of, so we're going to do A times B plus 3C transpose. So they're making me do a bunch of things to see if I can actually do that. And so you just do it one at a time, right? So this is equal to a 6 by 4 times a 4 by 7 plus. So scalars don't affect the dimension. So you would do C transpose, which would be, let's just write 7 by 6 transpose, okay? This is very unofficial notation. Like this, people don't really actually do it. This is how I do it, okay? So the transpose, you have to go back and look at the definition of the transpose. Notice right here, I said an M by N matrix becomes N by M, so they swap, right? So if I go back here, I'm not going to do the multiplication yet. I'm just going to do the transpose. 7 by 6 becomes 6 by 7. They swap order, okay? Transpose swaps order. And so if I look at it here now, I have this number and this number. They're equal to each other, which means I can do 6 by 7 like that. Because 6 right here, 6 right here. 7 right here, 7 right here. The two middle numbers are the same, right? These right here. Same. And now I have 6 by 7, 6 by 7. And when we go back to the rule of addition, the rule of addition says in order for two matrices A and B to be added, they must be the same dimension. So if I look, 6 by 7 plus 6 by 7 is 6 by 7. Now, to be clear, because I could see someone easily making this mistake, you're not multiplying anything, like in the sense of like, you're not doing 6 times 4 and 4 times 7. Like, that's just the notation we use to denote rows and columns, right? So whatever the best way is for you to actually write this out, by all means, this is how I do it. So maybe this helps you. If not, if there's a better way, then go do that one. But that is our dimension, 6 by 7, after we do all of our operations, okay? And just make a note of this to yourself. Scalars do not affect dimension. So when you multiply a matrix by a scalar, it does not affect the dimension because all you're doing is make the numbers bigger or smaller. You're not creating any new numbers in rows or columns, right? So we're good there. So now we're going to introduce how we actually multiply these together. Now, the official way of describing how these are multiplied is called the dot product, right? So the dot product is essentially how you multiply matrices, dot product. Now, in this class, we don't really go over the dot product in like super detail, but I'm going to explain it just because every single matrix multiplication problem is just a bunch of dot products, okay? So the dot product is multiplying a row matrix by a column matrix such that it results in a single number. And so one of the things that I think students struggle with in learning matrix multiplication is when I say 2 plus 2 is equal to 4, students understand that because they are taught to memorize that when they're, younger. 2 plus 2 is 4, 2 plus 3 is 5. Or maybe you're taught if you have 2 apples and you have 3 apples, when I put them together, I have 5 apples, right? And that's addition. Addition has a intuitive notion because we're just combining things, right? Matrix multiplication doesn't have that because I always tell students the reality of the dot product and matrix multiplication is some genius mathematician came along and thought, you know what? This works. This is a very convenient way of combining matrices that solves a problem I'm trying to solve. That's it. So there is probably some nice geometric interpretation that you could learn about the dot product, and it comes down to like length and stuff like that. But I'm telling you right now, in order for you to understand the dot product at that level, you'd have to learn so much extra like linear algebra and other stuff to like really understand it geometrically. You're basically doing like you're learning so much more to learn something at this level, right? It's like learning like why 2 plus 2 is 4. Like, well, 2 plus 2 is 4. I was told that. But if you ask the real question, like, why is that operation taking 2 things and 2 things and making 4 things? Like, why? Like, if you keep asking why, you'll run into a hole of like, okay, now I'm going too deep into like philosophy and stuff, right? So I just recommend memorize the technique. Like, don't worry about the why here because the why is just too complicated, in my opinion, right? So, how do we multiply a row and a column? Well, we do it this way. Let's just take a row, and I'm going to use a letter, A1, A2, and A3. You can make this as big as you want, but in this class, the biggest matrices that we tend to work with are 3x3s, maybe a 4x4 every once in a while, but really 3x3. But you know what? I will do 4x4 just in case you do a 4x4 later. So a 1, 2, 3, 4, that's a row. And then we're going to multiply it by a column, B1, B2, B3, B4, right? So again, if I ask you that question, if you got to choose the rule for multiplying these together, what would you want it to be? You would tell me most likely like the first one times the second one, like A1 times B1, A2 times B2, A3 times B3, A4 times B4. And your justification might be because the 1 and the 1 go together, the 2 and the 2 go together, the 3 and the 3 go together, and the 4 and the 4 go together because that just looks nice. Like that, my brain can remember that much easily, right? And the nice-ish part is that's kind of true. You are going to do that, but then we add this extra element of like, okay, now that you've multiplied them all together, right? A1, B1, A2, B2, A3, B3, and A4, B4. And I really hope no one pauses the video at this exact moment and stops watching, because if they do, this is completely wrong, okay? In the sense of like, you don't stop here, right? Like, that's how we wish it worked out, okay? But then there's this extra thing that we have to do now, and we're going to add them all together. Add, add, and add, okay? Again, now if you're wondering, where did the addition come from? Some genius mathematician came up with it, and that just works. That's all you should think about it for now. It's just how we combine two matrices, or sorry, a row and a column. We take the row, we multiply it by the column, and then we add them together, and then we get this nice number, which we call the dot product. Okay, so then it's just equal to A1, B1 plus A2, B2 plus A3, B3 plus A4, B4. Now, if you're wondering, hold on, where did the brackets go? Why did you get rid of the brackets? It turns out, and I didn't mention this earlier, but mention it now. A 1x1 matrix is equal to a number. So it's just a number. We don't really work with 1x1 matrices, but by definition, a 1x1 matrix is the same thing as a number. So if you're confused right now, perfectly understandable. But let's just do an example with numbers, right? Let's kind of work on that. And just to also illustrate this, this is a 1x4 matrix, and this is a 4x1 matrix, right? When I multiply them together, because the two middle numbers are the same, I get a 1-by-1 matrix, which is a number, right? So the matrix multiplication does work. So let's do an example. We're going to multiply 1, 2, 3 times 4, 5, and 6. So you should still always check dimensions, right? 1/3. It's just good practice. And then 3/1, they could always throw you a curveball in the exam where they give you something that doesn't work and people don't pay attention. They do all this extra hard work that amounts to nothing because the answer is does not exist. So always check the dimension. Okay. So 1 times 4. In fact, let's go back to some color coordination. So 1 times 4. Yeah, I don't like how that looks. 1 times 4 plus 2 times 5 plus 3 times 6. And as you can see, we now get a number when I combine all of these together like that. And so we get 4 plus 10, which is 14, plus 18, which is 32, I believe. Yep, 32. And that's the dot product. Now, you're not really going to call it the dot product. In fact, if you don't hear the word dot product in your class, don't be alarmed. It's not like huge, but that is actually how we define matrix multiplication. So now let's make the matrix bigger, right? So let's do another example. And when it comes to matrix multiplication, if you're doing it by hand, it's really all about practice, right? Just practicing it a few times. They could always make you do matrix multiplication on the exam and they force you to do it by hand because they say in the directions to do so. But if they don't, then maybe you could just use your calculator. And I'll show you how to do it on the calculator too. So I'm going to multiply these together. Actually, don't put the dot because we don't like that. Okay, so first thing you want to do is check dimensions. So step 1 is check dimensions. So 2 by 2, 2 by 2. Also, by doing this, this tells you how big the matrix is going to be when you actually multiply it. So it's a 2 by 2. Okay, so we're good. Now we're going to multiply. So step 2 is now actually multiply. So I'm going to do it up here. And because I know it's going to be 2 by 2, and again, if you're doing this by hand, this is how I recommend you do it. Start off with your left bracket like that, or parentheses if you're a parentheses person. But don't close it, because if you close it too soon, sometimes you won't give yourself enough space. And if you're a pen user like myself, then you can't get rid of that line, right? And so I want to ask you this very fundamental question. And if you understand this question, then you kind of have matrix multiplication down. I want a number, because this is going to be a 2 by 2, right? I want a number here. And I want a number here. Oops. And I want a number here. And I want a number here, right? Like fundamentally, that is matrix multiplication. I am trying to create a number in each of those 4 little areas. So my question to you is, what row and what column do I need to multiply using the dot product, or using this idea right here of taking a row times a column to make a single number? I need to do that here now, okay? So then ask yourself this question. If this is row 1, column 1, this is row 1, column 2, this is row 2, column 1, and row 2, column 2, right? Like if I were to label them out. So then ask yourself, row 1 is going to be this row right here, right? And then column 1 is going to be this one right here, right? So if I want row 1, column 1, which 2 am I going to multiply? I am going to multiply row 1 times column 1, right? Now, unfortunately, I don't have infinitely many colors here. I mean, I have enough colors to do so, but it's got to be careful here. So I'm going to multiply row 1 times column 1. right? Because I want the number at row 1, column 1. So then 1 times 5 plus 2 times 7. When I combine those together, I will get a single number, right? Let's just do that right now. 1 times 5 is 5, plus 14 is 19, right? I have created a single number in that location of the matrix. So then I go to the next one, and you can go sideways or downwards. I prefer to go sideways because that lets me fill out the matrix for a row to be able to close it. But I want row 1, column 2. So I'm going to do row 1 again, the 1, 2, but now I'm going to multiply by column 2. So I'm not looking at that one anymore. And then I say, okay, I'm going to multiply the 1 times the 6 plus the 2 times the 8. And if I do that, I get 6 plus 16, which is 22. And that's row 1, column 2. And then I repeat that again. But now I'm going down to row 2, column 1. So row 2, column 1, row 2, column 1. And the first number times the first number, 3 times 5. Plus 4 times 7. And then I do 15 plus 28, which I believe will be a 43. Yes. And then I got that number. And then I do row 2, column 2. So row 2, column 2, 3 times 6 plus 4 times 8. And that's 18 plus 32, which is a 50. And that is matrix multiplication. Now, if you're wondering, is there a faster way of doing it? Your calculator is the fastest way of doing it, but are there any patterns I can do? I mean, there is patterns, like if you notice 5, 5, 7, 7, 6, 6, 8, 8, right? If you go downwards, the numbers stay the same. And then 1, 1, 2, 2, 3, 3, 4, 4. So if you go across, there are numbers that are the same. In my experience, the patterns are harder to remember than the matrix multiplication itself. So yes, there is patterns that can kind of help you check your answer. And yeah, that's pretty much it. I'm actually gonna put, no, it's perfectly fine there. But that's matrix multiplication. We'll practice another example or two just to kind of keep seeing it. But the only thing that makes this more difficult is making the matrix bigger, honestly. That's what really makes these more challenging, is more numbers, more negatives, positives, fractions. If they threw fractions at you, that would not be very fun. But there also is matrices sometimes that look easy or simple, and they are actually very, very annoying, because when students think of row and columns, they think like rows have to be very long or columns have to be very long, but that's not necessarily the case, right? But let's just do another example of something that we're kind of going to get used to. So let's see. Gonna grab one here for us. Just making sure it's not too similar to the one we just did. Okay, here we go. 0, 2, 3, 1, -5, 6. So, and then let's do one like this. 1, 5, -2, 0, 3, 1. So 2 by 3 and a 3 by 2. So if we have a matrix like this, check dimension. And so we have a 2 by 3 and a 3 by 2. Then we have a 2 by 2. Okay. And so we're good. Now we multiply. So if we multiply, we are going to do 2 by 2. Now this is going to be longer, so let me color coordinate this like that. And then we need blue up here. And lavender down here. And yellow up here. Okay. So we're going to do row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. Okay. And so row 1 times column 1. And if you can do this mentally, that's great. Some people can't, and that's fine too. And so we just write down everything. So 0 times 1 plus 2 times -2 plus 3 times 3. And if we combine that into a matrix, or sorry, into a term, it's going to be 0, -4 plus 9 is a 5. And then now we do row 1, column 2. So row 1, column 2. So 0 times 5 plus 2 times 0 plus 3 times 1. So that's going to be 3 because of the 2 zeros. Row 2, column 1. So 1 times 1 plus -5 times -2 plus 6 times 1. And if we multiply it together, we get 1 plus 10 plus 6 is 17. Yep. And then row 2, column 2. 1 times 5 plus 0 times -5 plus 6 times 1. And I get 6 plus 5 is 11, right? So another case of matrix multiplication. Now, I'm going to do one more quick example because this is probably the most difficult one for students because, again, it just kind of goes against the notion of, what's it called? Rows and columns. So if I ask you to multiply this right here, 1, 2, 3 times, oops, sorry, wrong way. No, sorry, I was right. I was right the first time. 1, 2, 3. Give me 1 second here. Yeah. And then 4, 5, 6. I should be very careful now that I think about it. There's a little dot right here. Should put that little dot. Because that was a dot product. Yeah. I should have, yeah, that's kind of been multiplying a row. Hold on. Give me 1 second. Scratch all that. We're good. Let me just do the one that I was actually going to do. 1, 2, 3 times a 4 by 6. Yeah. So anything else saying about the dot? You don't need it. I was just looking at the wrong thing. Okay. So this is a 1 by 3. Sorry, wrong one. 3 by 1. And this is a 1 by 3. Now, are they going to throw this at you? Probably not. But so this becomes a 3 by 3, right? So 2 little rows and columns become a huge matrix, right? So this is probably the most difficult one because a row is, going across and a column is going up and down, right? So this is row 1, row 2, row 3, and this is column 1, column 2, column 3. So a row or column could be a single number. So row 1, column 1 is just 1 times 4. Row 1, column 2 is 1 times 5, and then 1 times 6, right? Row 2, column 1 is 2 times 4, 2 times 5, and then 2 times 6, respectively, for column 2 and 3. And then row 3 times column 1 is 3 times 4. Row 3, column 2 is 3 times 5. And then 3 times 6 for row 3, column 3. And that's our matrix. So this is one where you kind of have to remember that rows and columns don't have to be tall, okay, or long. They can just be a single number, right? And so that's matrix multiplication by hand. Now on a calculator, I kind of already know how to do this. Just take any two matrices, so second matrix, and then I do something like, okay, let's edit this right here. I'm not going to copy the numbers down, I'm just going to make it a 2 by 2. So if you want to multiply two matrices, you do second matrix A, second matrix B. You press enter, and there's your answer, right? Do second matrix. Now, if you do two matrices that are the incorrect dimensions, like A and C, you'll get dimension mismatch, and that tells you that something's wrong. Also, there's another command that you can do. I've never used it really, but there's dim, which just means dimension. The second matrix A, and it tells you it's a 3x2. Now, you could just go into the edit and see that. But, I mean, also, I mean, you could, I guess, now that I think about it, you could probably do something like the dimension of the product, and then it tells you it's a 3x2, it looks like. Well, is that correct? Let me check. Yeah. Let's just make this. I mean, I don't ever use that command, but could be useful for a homework problem or, you know, any problem like that. So second, enter. Yeah. So if you do dim and then type in that entire operation with numbers, it can easily tell you what the dimension is after all the operations. So I guess, I mean, it's kind of a slick way of doing it. If you don't even care what the numbers are, you just care what the dimensions are. So that's kind of cool. For anyone that watches the video and remembers that, that would be a nice little trick for a problem like that. So now let's talk about an important topic within matrix multiplication. So matrix equation form of a system. So one of the things that we learned in chapter 1 was the system of linear equations, right? Like, let's just say we had something like x plus y minus z equals 3, 2x minus y plus 4z equals 8, and then negative x plus 2y minus 5z equals 3, right? If I ask you to solve this, you would say, okay, well, I got to do elimination method and substitution method. That's not going to be fun. Well, what if there was a way of converting this into a matrix where I can do, you know, stuff with it, right? And that's going to be kind of the goal, is to be able to convert something like this into a matrix. And so fundamentally, you can do that through matrix multiplication. So if you think about it, I want to multiply this. So I'm going to convert into matrix form. And so if you're ever asked a question, convert it into matrix equation form, they're really just saying convert it into a matrix times a matrix equals another matrix, right? So you're going to have three matrices, a big one, a tall one, and another tall one, okay? And if you just think about it from look-wise, I see an equal sign and I see an equal sign. So on the right side of the equal sign, I see 3, 8, 3, and they're stacked up on top of each other. So if I'm thinking matrices, well, matrices are just rows and columns of numbers. Logically, it would make sense to put 3, 8, and 3 here because of how they're stacked up. Well, here's the good news. That's exactly how it works out too. Okay. So then, okay, that one kind of makes sense just from looking at the system. But now I got to think about the left side, because the left side is a lot trickier. It has variables and numbers. Well, if you think about it, what letters are there? Well, there's X, Y, Z. And all three equations have X, Y, Z. They don't change, like they don't become a different letter like W or Q. So if I have three letters every single equation, well, what if I just make this one X, Y, and Z, right? Because it's just, those are the only three letters I care about. And I think to myself, okay, matrix multiplication. I have to make sure the dimensions match up. So if I look at the answer, this is 3 rows and 1 column. Okay. And this right here is 3 rows and 1 column. So far, I'm good because this number matches this number. And that tells me, okay, in order for this matrix multiplication to work, this has to be 3 because these two have to be the same, right? By reverse engineering. And then if those are the same, then this number right here has to be here. So that's 3 by 3, okay? So then I think to myself, okay, what could I fill in there that's 3 rows and 3 columns? Well, I say, well, what about the numbers in front of X, Y, and Z? Well, in front of X, there's a 1. In front of Y, there's a 1. And in front of Z, there's a -1 for the first one right here. Right? Row 1 is equation 1. And then I go to the next one. 2, -1, 4. And then -1, 2, and -5. And then I see, okay, now I have the matrix equation. And the best part about it is if I do multiplication, right? Let's just multiply it. Row 1 times column 1. 1 times X plus 1 times Y plus -1 times Z is equal to 3. Then I get X plus Y minus Z equals 3, which matches up with the first equation. So that is the matrix equation of a linear system. I've been able to verify and match them up. So I'm going to write that more nicely. To verify matrix equation, multiply row 1 and column 1. 1, 1, -1, X, Y, Z is equal to 1 times X plus 1 times Y plus -1 times Z. And that's going to be equal to the third one right here because it's the first entry in that one. And then we get X plus Y minus Z equals 3. And there we go. And so that reinforces that we can write any linear system as a matrix. And we're going to call this matrix right here the coefficient matrix. This right here is our variable. And then this right here is our constant. Okay, so our constant matrix. And so one of the things that you're going to practice in the first set of homeworks is just conversions, right? Converting it into a system. And then maybe they ask you to multiply out a matrix system back into system form. So let's just practice that real quick. So convert the system into matrix form. So 4x minus 2y equals 3, and then 5x equals 7. So this also begs the question, what if I'm missing a number, right? So step 1, set up matrix equation. So that, and that. And just fill in. So, and fill. So the variables are always this one, x and y. And if you're wondering, whoa, equation number 2 doesn't have a variable. As long as the variable shows up once, that's all you need to write it down once, okay? So one time. And then 3 and 7. And then just go by. So I like to put the variables because the variables also correspond to the columns. So if you want to go vertically, for x variable, it's 4 and 5. And then for y variable, it's -2 and 0. If you want to go horizontally, you're more than welcome to do that. I prefer vertical, but it's personal preference. Okay. We can denote the matrix equation as AX equals B. And so these are the coefficients, variable, and then constants. So if a question says write it as AX equals B, that's the matrix form, okay? It means the same exact thing. And of course, the reverse problem of this is, what if I ask you to simplify? Convert a matrix back into system form. Right? So convert that back into system form. Well, you just do row by column, right? So row 1 column 1 would give us 1 times x plus 2 times y plus 3 times z equals -11. Okay. Let's do it this way. This and this give us this. Which become x plus 2y plus 3z equals -11. And then I go to the next one. Because the variables are going to be the same for all of them, right? So -5 times x plus 6 times y plus -7 times z equals -12. And so I get -5x plus 6y minus 7z equals -12. And then the last one, we get 8 times x plus 9 times y plus 10 times z equals 13. 8x plus 9y plus 10z equals 13. And that's how we simplify it. So not too bad. You'll have to go one between the other. Sometimes they'll do them with commas in between, so like a comma and a comma. So however the homework wants you to separate them or anything. But that's matrix multiplication in terms of systems, right? We're going to be using that a lot. And so the final thing to kind of wrap up the notion of matrix multiplication is the matrix properties, right? So matrix multiplication properties. And then we could do one more of those examples where we do the check the dimensions and distribute, right? So we are going to have kind of like four basic properties. There's a lot more, but these are the ones that you really kind of need. So given, let A, B, C be m by n matrices where multiplication is defined. So if you can't multiply the matrices, then none of these rules work, right? So you have to, by default, be able to multiply them. Rule number 1 says A times B times C is equal to A times B times C, which hopefully would be true. But the thing we're saying here is that if you multiply the first two or the last two, you get the same answer. So we call it associative. Okay, it means you can do that. Another property that is very important, and this is kind of the big one, when you multiply two matrices, the order does matter, and A times B does not always equal B times A. Okay. Really, there's kind of 3 exceptions. So 3 exceptions. And we'll talk more about those later. But that's going to be when you're multiplying by 0, by essentially 1, and the inverse. Okay. But generally speaking, order does matter. And then number 3 says if you multiply a matrix on the left side of parentheses, you have to distribute on the left side. We call that left distribution. And then if you multiply matrices on the right side of a parentheses, then you have to multiply on the right side as well. So again, this just goes back to the second condition that order does matter. Another thing, if you multiply a matrix by a number, you can kind of put that number wherever you want. For a number alpha. So that doesn't affect the matrix multiplication if there's a number in the way. So we're going to practice one example of using these properties, and then that essentially covers matrix multiplication in its entirety. So example. let A be equal to 1, 2, 3, 4. B be equal to 5, 6, 7, 8, 9, 10. And C be equal to -1, -2, -3, -4, -5, -6. And we're going to use the calculator for this one just so that we can practice one more time. Compute A times B plus 3C. Right? What if I want to do something like that? Well, if we go to our calculator, okay, let's clear all this out. Second matrix, we're going to go to edit. We're going to make this a 1 by 1, put a 0 there, and then we can now make it a 2 by 2. And we're going to do 1, 2, 3, 4. So that's our 2 by 2 matrix. Second matrix, hit the right arrow key 2 times, go down to edit for B. 1 by 1, put a 0 there. And this is going to be 2 rows, 3 columns. And so that's going to be 5, 6, 7, 8, 9, 10. That's our 2 by 3. Second matrix, now we're going to go to C. Going to make this, oops, press the wrong button there, sorry. Second matrix, edit, C. Going to make this a 1 by 1, put a 0, and then make it a 2 by 3. And then I've got a bunch of negatives here, so we got to be careful. -1, -2, -3, -4, -5, -6. So all of our matrices are set up. Second quit, second matrix. And then we're going to do, okay, so we're doing A, left parentheses, second matrix, B, plus 3, second matrix, C, close parentheses. And if we press enter, we have invalid dimensions because I think I wrote down the wrong one. Let's see. 2 by 2. 2 by 2 times a 2 by 3 plus a 2 by 3. No, it should distribute incorrectly. So maybe calculators don't like doing that. So that could be a thing where I forget that it doesn't like doing that. You know what it might be? Sometimes stuff like this. Second insert times. There we go. I guess it doesn't like it being next to the parentheses like that, so you have to put a star. So let's write that down. -6, -12, -18. -6, -12, -18. And then -10, -24, and then -38. So on calculator, you need your multiplication symbol. Make sure to multiply before parenthesis. So A times B plus 3C, like that. Okay, so just a little calculator thing that you have to deal with, right? So, nothing too bad. But that's matrix multiplication. If you can use your calculator, by all means use it. Don't really do these by hands if you can avoid it, but it is important to at least practice it a few times so you get a good feel for it.